Hello guys and welcome back. Today we're going to talk about a very important subject in the electrical and electronics field. Not only that, but this is part of the California state exam, so some of these calculations, not these exact calculations that I'm going to show you, but the method and type of calculations we could say serious in this type. So today we're going to talk about series circuits. Tomorrow we're going to talk about parallel circuits. These both are very important in and within the state exam. So please pay attention and thank you for joining me. We're going to talk about series circuits, voltage dropped in a series circuit, resistance in a series circuit, calculating series circuit values, solving circuits, voltage dividers, the general voltage divider formula, voltage polarity, using ground as the reference. Electrical circuits can be divided into three major types: series, parallel, and combination. Combination circuits are circuits that contain both series and parallel path. First type discussed is the series circuit. The series circuit has only one path for current to flow. Because there is only one path for current to flow, the current is the same at any point in the circuit. Imagine that an electron leaves the negative terminal of the battery. This electron must flow through each resistor before it can complete the circuit to the positive battery terminal. One of the best examples of series connected device is a fuse or a circuit breaker. Since fuses and circuit breakers are connected in series with the rest of the circuit, all of the circuit's current must flow through them. If the current becomes excessive, the fuse or circuit breaker will open and disconnect the rest of the circuit from the power source. Voltage drop in a series circuit. Voltage is the force that pushes the electrons through a resistance. The amount of voltage required is determined by the amount of current flow and resistance. If a voltmeter is connected across a resistor, the amount of voltage necessary to push the current through that resistor will be indicated by the meter. This amount is known as voltage drop. It is similar to the pressure drop in a water system. In a series circuit, the sum of all the voltage drops across all the resistors must equal the applied voltage to the circuit. The amount of voltage drop across each resistor will be proportional to its resistance and the circuit current. Resistance in a series circuit. Because there is only one path for the current to flow through a series circuit, it must flow through each resistor in the circuit. Each resistor limits or impedes the flow of current in the circuit. Therefore, the total amount of resistance to current flow in a series circuit, it's equal to the sum of the resistances in that circuit. Calculating series circuit values. 3 rules can be used with Ohm's law for finding values of voltage, current, resistance, and power in any series circuit. The current is the same at any point in the circuit. The total resistance is the sum of the individual resistors. The applied voltage is equal to the sum of the voltage drops across all resistors. A good rule to remember when calculating values of electrical circuits is that the total power used in a circuit is equal to the sum of the power used by all parts of the circuit. That is, the total power can be found in any kind of circuit, series, parallel, or combination of both, by adding the power dissipation of all the parts. Voltage dividers. One common use for series circuits is the construction of voltage dividers. A voltage divider works on the principle that the sum of the voltage drops across a series circuit must equal the applied voltage. Voltage dividers are used to provide different voltages between certain points. Voltage dividers can be constructed to produce any voltage desired. For example, assume that a voltage divider is connected to a source of 120 volts and is to provide voltage drops of 36 volts, 18 volts, and 66 volts. Notice that the sum of the voltage drops equals the applied voltage. The next step is to decide how much current is to flow through the circuit. Since there is only one path for current flow, the current will be the same through all the resistors. For example, a current flow of 15 milliamps will be used. The resistance value of each resistor can now be determined. The general voltage divider formula. Another method to determine the voltage drop across series elements is to use the general voltage divider formula. Since the current flow through a series circuit is the same at all points in the circuit, the voltage drop across any particular resistance is equal to the total circuit current times the value of that resistor. Voltage polarity. It is often necessary to know the polarity of the voltage developed across a resistor. Voltage polarity can be determined by observing the direction of current flow through the circuit. Using ground as a reference. 2 symbols are used to represent ground. Earth, its ground symbol, and it symbolizes a ground point that is made by physically driving an object such as a rod or a pipe into the ground. Chassis ground is the point that is used as a common connection for other parts of a circuit. And this is the end for series circuits theory part 1. Next, we're gonna go to the exercise part, or part 2, in the series circuits lesson. Stay tuned, and thank you again for watching.